So remember, inverse notation, you're going to see that negative 1. That does not mean a power in any way, shape, or form. What the thing you want to kind of highlight are these two facts right here, is that if y is f of x, then x is f inverse of y. So that notation is super important. And then these 3 steps, please write those down. To solve for an inverse, you're going to first solve for x, then you'll switch the x and y out, and you'll use inverse notation. So in the first example in problem number 6, it says that define the inverse function for each of the following functions. So we're going to start with A, and I'm going to show you how to find the inverse for a linear function. So the first thing we want to do is we don't want the f of x showing initially. We're going to write it as y equals 3x minus 7. And then we want to solve that for x. So just think about, how would I rearrange it and make it a function in terms of y's instead of in terms of x? So we want to add 7 to both sides, and we want to divide by 3. So that's what I mean when I say to solve for x. So we've done step 1. We have solved that for x. And then we want to actually use inverse notation, but we can't do that until we switch the x and the y. So now, every place you see an x, write a y. Every place you see a y, write an x. So it's going to be x plus 7 over 3 equals y. So we took out the x's, made them y's, and then y's and made them x's. And then we're going to write it in inverse notation. So you put that little negative 1 power by the f, whatever your function happens to be called. Our function is f, so we call it f inverse. So that is our answer. So for this mod 3.6, to find the inverse, let's go over what we did one more time. We solved the original for x. We switched out the x and the y. We used inverse notation. So watch what we did one more time for 6a. So we took the original function, used y notation, solved for x, switched the x's and the y's, found the inverse. So that is how you would want to get started on these, okay? So now let's take B and do the same exact thing. So they called J var is actually W. So let's write it like that. So you take off the inverse notation. I could have made that kind of maybe my first step. Now this time we're not solving for x, we're solving for r. You're going to always solve for whatever this particular inside thing was. So we're going to solve that for r. And we're going to do that by multiplying through by 6. Add 5 to both sides. Because there's a 2 on the r, divide both sides by 2. So our inverse is, or our r is 6w plus 5 divided by 2. Now what do we have to do next? We got to flip-flop the w's and the r's. So it's w equals 6r plus 5 divided by 2. Now our initial inverse, or our initial function was j's. So now we put the inverse notation back in. So J inverse of R is 6R plus 5 divided by 2. Okay, so let's go over the rules one more time. So this is mod 3.6 investigation. Okay, so we are going to write this with the variables W and R. So I just wrote it as W instead of J of R. And then I solved for the opposite variable. In this case, we're going to solve it for R. Then we're going to solve it for W, I'm sorry. And then we are going to put the inverse notation back up. So basically, you solve for the opposite variable, you flip-flop them, and you put the correct notation. You solve for the opposite variable, you flip-flop your variables, and you put on the inverse notation. So the inverse is what you see right here. So it's all about switching, because an inverse's job is to take the X and Y and switch them. Look at what we see up here. The X and Y has switched. So you're going to solve for the opposite variable. You're going to switch those variables, and then you're going to use inverse notation. Okay, so let me say it again. We're going to solve for the opposite variable. We're going to switch the variables, and then we're going to use inverse notation. So now, let's go ahead and look at a graphical problem, okay? So it says that a ball is dropped off the roof of a building. The given graph of the function f represents the ball's height above the ground in feet, h, in terms of the number of seconds since the ball was dropped, t. So I'm going to write a little note to myself that f of t is equal to h. So the points are always going to be th. This is in seconds. This is in feet. We can see on our graph, if we are to scooch in a little bit, that our number of seconds is our independent variable, our x. The number of feet is our dependent variable, our y. Okay, so making yourself a little note of that is going to be really important. So when they say, what does 4 represent in this situation? Okay, so this is the height at 4 seconds. But B is different. B says F inverse of 4. So that means instead of being I plug in T, I get out H. I plug in H, I get out T. So that is saying what is the time at a height of 4 feet. See the difference, how they flip-flopped? So let's go to the graph. They didn't ask us to, but I want to go to the graph and find out what that is. So f of 4 looks to be, let's go 110. So f of 4 looks to be 110 feet. But the inverse of 4 means that we're at a height of 4 feet. So I would say that's maybe right about here. The time is somewhere between 4.5 and 5, a little closer to 5. So let's go that looks to be about 4.8 seconds. So you have to realize what these things are talking about. Okay, now let's jump then to C. It says estimate the value of the inverse at 250. So we know that our height is 250 feet. The question is what is our time? So we're going backwards. When that uses that notation, our H and T flipped. So now the inside stuff is the height, the output is the time. So if we are at a height of 250, estimate what is the time. So let's put a little dot at that point. And if we go down, it looks like it's somewhere between 2.5 and 3. Let's call it 2.8. You're going to just guesstimate at that point, just guesstimate. I don't know exactly what that means. Now in D it says what is or where is f of t equal to 75. We could really write that as where is the inverse or what is the inverse function at a height of 75. That's how we could write that, because that is an output of time. So if we go to 75 and we go to that point, let's mark that point right here. It's somewhere between 4 and 4.5, closer, I think, to the 4.5. So let's call it 4.3 seconds. So our time is 4.3 seconds. So inverse notation just goes backwards. Inverse notation just goes backwards. So it's very useful to write down what the original is showing you. So if you see that little -1 notation next to the function notation, you know that that's going to reverse. So the input then, in this case, would become height. The output would become time for our inverse function. Everybody good with 7? Okay, so now that we've done a graphical interpretation, let's go ahead and look at a chart, okay? We're not going to do all of these. Let's do the ones where there is a little star next to them, at least. We'll do those. Well, yeah, that's fine. Okay. F of 0 means that if our x is 0, what is our f of x? So if our x is 0, our f of x is 4. So the answer is 4. F of 0 equals 4. Let's do B. Now here's different. This is saying if our function is 3, what is our x? If our function is 3. So this time we're going to start at the function location, because that's what the inverse tells us to do. We are going backwards. So if our function is 3, our x is -1. So that equals -1. Now let's do a composition. Let's do E. Now we always start from the inside first. What is g of 2? That's a normal one. We're starting at an x value of 2. We're going over to our g function. We get an answer of -1. Let's say that again. We're starting at 2. We go to our g function. We get -1. But this is an inverse, so we're going to start at our function, work our way back to the x. So if we get a function value at -1, what x did we start with? The answer is 1. See how we use the chart backwards. So let's do F. We're going to use the chart backwards. If our function value is 6, our x value is 2. This right here goes to the x value of 2. And then if we start at our g function with a y value or a g of x value is 2, we go back to an x value of 0. So that's very important. And then finally, the last thing I want to talk about as far as 3-6, and then you're going to have your investigation for 3-6 ready to turn in, is composing of inverses. Now, to compose inverses, think about the fact that f of a equals b and f inverse of b equals a. So the domain of f is going to be the range of f inverse. The domain of f inverse is going to be the range of f. They flip-flop their x's and y's. So if I compose this, see how I started with a, I came back to a. If I compose it this way, I started with b, I come back to b. So you just have to think that it undoes each other. If I take f of f inverse, I go right back to where I started. If I take f inverse of f, I go right back to where I started. That's the main thing. So what's interesting is that means two inverses will always undo each other and go right back to the x in which they started. So for 9, it says, your classmate believes that each of the following pairs are inverses. Is your classmate correct? Now, if the classmate is correct, if we compose them, we should always get x. Okay. So what does that mean? Let me show you. We'll start with 9a. So let's do g of f of x. Both ways should get us an answer of x, because the x becomes the y and then the y becomes the x. It goes right back to where it started. So let's take and put our function 2 times the quantity of x plus 1 minus 8. Let's put it right into our g function. Okay, now watch what happens. If it's correct, the 2 times the quantity of x plus 1 minus 8 plus 8 over 2 minus 1 should give us an answer of x. If not, it's not the inverse. Okay, so the plus 8 and the minus 8 cancel. That's a good sign that because these things cancel, we're on the right track. So then we'll get 2 times the quantity of x plus 1 divided by 2. And then we'll get x plus 1 minus 1, which gives us x. Yay! I've just shown that I inputted x into the f function. That was inputted into the g function, and it went right back to x again. So that is saying, yes, these are inverses. And if I put the g function into the f function right there, the same thing should happen. Or guess what? They're not inverses, okay? Now, let's check it for b. They wanted us to check g of f of x and to check, do we get x again? Okay, so let's put f of x inside here. That tells me it goes right here. So we're going to get 4/3 of that quantity, 3x plus 7 over 4, minus 7. Now, the 4's cancel. The 4's cancel. That's good. But here's the problem. The 3 doesn't completely. So what happens is the 4's cancel. Yay. So let's chop those off. Okay. But we get 3x plus 7 divided by 3. Mathematically speaking, the 3 isn't only dividing into the x, it also has to divide into the 7. So we get x plus 7/3 minus 7, which is not x. So it's not the inverse. So however we compose it, if we don't get this x becomes y, then y becomes x sort of thing happen, then they are not inverses because they didn't switch each other's domains and ranges correctly. So since this answer is not a perfect x, it's not the inverse because it didn't do its job. So this would be, no, it's not the inverse. First one's okay. Okay. Now let's look at 10. It says that these classmates are all debating about this f inverse. We know that f of 7 equals 2. So f inverse of, we can write down to the side, f inverse of 2 has to equal 7. See how it flipped the input and output. So this one is incorrect. it didn't flip-flop 7 to become 2. It flipped, or it didn't. I don't know what the inverse does with 7. They didn't give us enough information. All I know is this, that F inverse of 2 is equal to 7. So that's this one out. But this should be true. Now let me show you why. F inverse of F of 7, F of 7 is 2. And I know that becomes 7 again. So Michelle is the only one that is correct in this particular instance. So we're going to now stop. We're not going to worry about 11. Please turn in your mod 3.6. You should have watched the video on Friday or over the weekend for the first part. If you haven't, please do that and turn this in today. And then could you please go into iMath, and could you please open up homework M36 on the calendar that is due today. Please open up homework M36 on the calendar that is due tonight. Now, there are some that are crossed out. Please ignore those. We're only going to focus on some of these. Now, we're not going to do all of these, but we're going to get some of these done. We're going to get some of these done together right now. Okay, so in problem number 1, so you should be at your homework M36 on the calendar that says today, and it says that Chris and Jen decide to go apple picking at a local apple orchard. As the number of apples they pick increases, the cost of the apples also increases. The function f relates the varying cost of Chris and Jen's apples, C, in terms of the varying number of apples that Chris and Jen pick N. So let's highlight for ourselves, or you don't, if you we'll have a sheet of paper or something, that C is f of n, and here is how f of n is defined. So it says, which of the following describes the meaning of f prime, or f inverse, I'm sorry, of 35. So f inverse of 35, remember the f inverse, this is the cost. So the cost is $35. The whole thing would be the input of our other function. So this would be the pounds. So it would be really what we see right here. The number of pounds of apples that Chris and Jen pick when the total cost is 35. So we input cost because that is our output of our original function was cost. And that's what that tells us right there, okay? So that's the number of pounds. So to evaluate 35, we have to go in the opposite direction. We know our function, our cost function, gave us 35. So you just have to solve that. So, and yours might be different than mine, so adjust yours accordingly. So you might need a calculator at this point. But we're going to subtract 6 from both sides. So in my case, I'm going to do 35 minus 6. I'm going to get that 0.35 n equals 29. And I have to divide both sides by 0.35 for an answer for me of 82.857 pounds. So that's how many pounds of apples that were picked for the price to be $35, the cost to be $35. You see how we set it? It's the output of the other, so we have to set the function equal to 35. So to determine the rule, we actually have to flip-flop, okay? So let me show you. The first thing we do is we take our function, write it with our variables. In this case, instead of x, y, they use n and c. We're going to solve that for the opposite variable. Okay, so we're going to subtract 6 from both sides. And then we're going to divide through by 0.35. So n is c minus 6 divided by 0.35. So I guess we just solve for the new variable. And so in this case, it's c minus 6 over 0.35. I guess that's because they use that c right here. So sorry about that. They just want this. Okay, so hopefully you got your iMath to do what you need your iMath to do. Everybody good with, again, adjust yours accordingly. Gotcha. Oh, gotcha. Did you get it to work? It's look like everybody's did. Gotta love it. Having a good day today, aren't we? Did you get it back? Is it working yet? Okay. For my other classes, I'm going to just do a few more, and you can always revisit this when iMath is working. I'm sorry. Okay, so number 2 says Brian and Casey's babysitter charges a base fee of $10 and then $7 per hour for each hour of babysitting. Define a function that determines the total price that they will pay C in terms of the varying number of hours that she will watch the children in. So we know that C equals 7n plus 10, or 10 plus 7n, however you want to write it. If we write that in function notation, the function of n is 7n plus 10. And then it says if Brian and Casey do not want to spend more than $60 on babysitting, how long can they stay out? So we would just say we want to spend $60. That would be our cost. So we know that 60 has to equal 7n plus 10. And so if you solve it, you would subtract 60 from, or 10 from both sides. We would get 50 equals 7n. And then 50 divided by 7 would be 7.1429 hours. And then define a function g in terms of the number of hours. We're going to go backwards. So let's solve this for the opposite variable. So we're going to subtract 10 from both sides, divide by 7. So we would say that g of c equals c minus 10 over 7. Okay, so that will get you started with the homework. Again, the ones that have been crossed through, please cancel, or just don't worry about that. So make sure you've turned in your 3-6, and there you go with that.